Hello, my name is Steve Bowler, and in this video we're going to be taking a look at RIP version 2. Specifically within RIP version 2 we're going to be taking a look at how the passive interface command works within RIP version 2. And what we can see here is that we have 4 routers in our topology: router 1, router 2, router 3, and router 4. Now, router 1 is connected to router 2 and router 3 via point to multipoint frame relay connection using its physical interface. So router 1, 2, and 3 are connected to each other using their serial 00 interfaces, and they are all in the 172.16.1.0/24 subnet. Router 2 is the .2, router 1 is the 1, and router 3 is the 3. Also, we have another network down here going to router 4, the 192.168.14.0 network. So router 1 is in the 1 network for that subnet, and router 4 is in the 4 IP address in the 14 subnet. And again, these are all the loopback interfaces. They all have loopback 0 interfaces respective of their router IP addresses. So router 1's loopback is 1.1.1.1/24, router 2 is all 2's, router 3 is all 3's, and router 4 is all 4's. So what we're going to take a look here as is what the passive interface command does within RIP version 2. And what we're going to see here is that what the passive interface command does is that it stops sending updates out the interface in which it is specified. So first off, the passive interface command, you can specify it globally, and it will apply to all of your interfaces in which you are running RIP on. Or you can specify to run passive interface on a per interface basis. So you would do like passive interface and then fast Ethernet 00 or serial 00. Or if you want to do it globally, it's just passive interface default. So we're going to take a look at its behavior and see what exactly is going on when we have passive interface enabled. So let's go ahead and get right to it here. So again, let's go into router 1. If we just do a show IP interface brief, we have the connection to it's a serial 00 connection. Let's go ahead and configure the the fast Ethernet 00 with 192.168.14.1, and that's a /24 subnet mask. Let's go ahead and do a no shut here. If I do a show IP protocol, let's see if I have any routing protocols running here, and I do, and it's RIP. So if I do a show run pipe to begin RIP, you can see here that we have our gateways, router 3 and router 2 as neighbors. So we have version 2 specified, no auto summary, and we are advertising our network 172.16.0.0. If I do a show IP interface brief, so we do have a loopback here, loopback 0. Let's go ahead and advertise that into RIP. So let's do network 1000 and hit enter. And that should be it. So if I do a show IP protocols now, you see our routing for the 1 network and the 172.16 network. And this is being enabled on the serial 00 and our loopback 0 interface. So what we want to do here is go under RIP again and do network 192.168.14.0. So it's going to encompass our network going to router 4. So if I do a show IP protocols, Now you can see our 14 network shows up for networks in which we're routing for. Alright, so on router 1, if I do a show IP route, you can see here that we're learning of the loopbacks of router 2 and router 3, and we can ping them. And if you're following me from the last video, RIPv2 Lab 3, which is on IP, split, it's going over split horizon within the RIP non-broadcast multi-access frame relay network type using physical interfaces. If you're following me from that video, the configuration set for router 1, 2, and 3 is pretty much exactly the same, except for on router 1 we're adding the Fast Ethernet 00 interface here, which is connected to router 4's Fast Ethernet 00 interface. So everything else is the same except for the connection to router 4. So if we go on to router 2, do a show IP route, you can see all of these networks. We're learning router 1's loopback, the network between router 1 and router 4, and we're seeing router 3's loopback interface as well. If we go to router 3, do a show IP route, same thing here. We're seeing router 1's loopback, router 2's loopback, and we're seeing the network between router 1 and router 4. So last thing we got to do here before we start going into passive interface, we'll go to router 4 and get it configured. Let's go ahead and configure the loopback 0 interface first. All 4 network /24. Going to the Fast Ethernet 00, we'll give it an IP address 192.168.14.4/24. We'll go ahead and do a no shut. And then we'll go under RIP. We'll do a no auto summary to turn off summarization at classful network boundaries. Then we'll go ahead and do a version 2. Next thing we want to do here is, let's go ahead and take a look at the passive interface command. As you can see here, we are under RIP router configuration mode. You can see here that we have a option for passive interface, and this is going to suppress routing updates on an interface. Again, the router will still listen for these RIP updates to come in, and it will update its own routing table. And the router is also going to advertise the interface address in the normal updates to peers. So basically we're going to see, let's go ahead and, if we go ahead and do a passive interface here on router 4, you can see here that we have the command for default. So this is going to suppress routing updates on all interfaces. So if I do a passive interface default here, that's going to apply to all of our interfaces that are running RIP. So in this case, Fast Ethernet 00 for the 14 network. Or I can go ahead and just do it under for an interface. So passive interface, Fast Ethernet 00. What I'm going to show you here on router 4 though first is we're going to go ahead and just do a passive interface default. And we'll go ahead and do a debug IP RIP. So we'll go back into RIP now, and this is our first option here, is we're just going to play around with passive interface default and see how this affects router 4's relationship to router 1. Go ahead and put the network statement here, 192.168.14.0. Actually, let's do it for the 4 network first. Let's go to router 1 here, which is connects, router 4 to the rest of the RIP domain. Go ahead and do a debug IP RIP. Okay, so on router 4 we'll do a network 192.168.14.0 14.0. So if I go ahead and try to ping router 1, let's do a 192.168. Actually, hold on a second. Let's do an all on router 1. As you can see, I have received a version 2 update from router 1 with all the networks that I need reachability to. So let's go ahead and do an unall here on router 4. Now what you can see here is on router 1, if I do a show IP protocols, is that I do not see router 4 as a neighbor. So if I do a show IP protocol on router 4, I do see router 1 as a gateway, because what happened here is router 1 started sending these updates out its Fast Ethernet 00 interface, and once it did that, with router 4, what we have to remember about the passive interface is it stops sending updates out the interface specified. So in this case, what we saw here is we saw all the updates that router 1 was getting, and router 1 did not have passive interface enabled on any of its interfaces. So it took these updates and sent them out to router 4. Even though router 4 has passive interface default command on it, what we're seeing here is that it still was able to receive updates and update its routing table. So what I'm showing you here is one of the key things with passive interface is, even though it's on router 4 here, we put passive interface on its Fast Ethernet 00 interface, it's still going to listen to the RIP updates and update its routing table, because it did receive an update packet from router 1. So if we go to router 4 and do a show IP route, you can see now that we're seeing all the RIP learned routes. We're seeing router 1's loopback, router 2's loopback, router 3's loopback, and the network in between all those routers. So if I go ahead and try to ping like router 3, what we're seeing is that we do have reachability. So what I'm going to show you here now is, if I go around and go onto router 1, we'll do this. We'll go into router RIP, and we'll go ahead and do a passive interface Fast Ethernet 00. So what we should see happen here is that these updates, we will stop sending updates out the Fast Ethernet 00 interface. So in this case, Fast Ethernet 00 on router 1 is going to router 4. So in this case, what we're going to see here is that router 4 is not going to be receiving, or should not receive, any of these updates. If I go to router 1, again on router 1, if I do a show IP protocol, I'm sorry, I'm on router 4. Let's go to router 1. You can see here that we have the network statement in for, the network between router 1 and router 4. Again, 2, here we have that on router 4. So again on router 1, if I do a clear IP route, so flush my routing table, we'll do a debug IP rip on router 4, and what we should see here now whereas before, when we didn't have passive interface on the Fast Ethernet 00 interface on router 1, we were seeing updates being sent out Fast Ethernet 00 as multicast 224.0.0.9. So we'll let this run for a second. We'll let these, updates come in. And as you can see here, looks like we are receiving updates and sending updates. Looks like, only out the loopback 0 interface and the serial 00 interface. So as you can see there, once we put the passive interface command on router 1, we stopped advertising these RIP updates out of that interface. So on router 4, if I do a show IP route, let's do this, we'll do a clear IP route. As you can see now on router 4, even in its routing table, these routes still show up, but it looks like here that it says, is possibly down. So what we're seeing here is if I do a show IP rip database, here's a better view of all the routes. You can see now, looks like all of our RIP learn routes are possibly down. And that is because we are not receiving these updates anymore from router 1. As you can see here, our last update was about 4 minutes ago from router 1, from router 4's point of view here. So after 240 seconds, we're going to flush all these, you've got to wait for the timers to run, and then, all these routes are going to be flushed out of the routing table. Let's see, 60, 240 divided by 60. So what is that? 4 minutes or so. So if I do a show IP route now, as you can see, our 4-minute timer, we've gone over 4 minutes. The flush timer has taken in effect, and we have flushed all those networks out of our routing table that were possibly down, which we didn't receive updates on. So now you can see here the passive interface in full effect. What we're seeing now is that router 4 is not receiving any routes from router 1, and we are showing here on router 1 that we are not sending any updates out serial 0, I'm sorry, we're not sending any updates out Fast Ethernet 00. So it's very important that we are aware of passive interface, because in some cases we might get a task where they want us to send updates only out specific interfaces. Well, if you have a network command that encompasses, the 10 network, but you have, 10 interfaces on your router that have, that 10 network in the IP address on the interface, and they say, hey, we only want you to send, these updates out this specific interface, for the 10 network. Well, the best way to do that would probably just to do a passive interface default, and then go under the one interface in which they want you to run the 10 network on, and do a no passive interface on that specific interface. So that way you can send updates out. So again, with passive interface enabled on in specific interface here, for instance, router 1, this is a good example. On its Fast Ethernet 0.0 interface, we have passive interface specified. What this is going to do is it's going to block updates, all of these, router 2 and 3's updates from getting to router 4. However, router 1, by the rules of passive interface, router 1 will still be able to listen to these RIP updates and update its routing table accordingly upon receipt of these updates. So if router 4 has a network here, it's going to be able to send these out to router 1. So what we should see is the 4 network on router 3 and router 2. So let's go back to router 4, but we have to remember on router 4 that we do have passive interface default on router 4's Fast Ethernet 0.0 interface. So actually we have it on all the interfaces. So if we do that's why if we do a show debug, we have, debugging is on, but it's not showing anything going on, and that's because we have passive interface on this interface here, and we have passive interface on router 1's interface going to router 4. So router 1's not sending any updates to router 4, and router 4 is not sending any updates to router 1. It's a bad situation here. So if I go ahead and go back under RIP here and do a no passive interface default, what we should see here is we should see some information come up right away here with our debug on, and we should try to send out this 4 network to router 1. Router 1 should still update its routing table and pass this information on to router 2 and 3. Because right now if I go to router 3, do a show IP route, as you can see here, we don't see the 4 network. We do see the network between them, but we do not see the 4 network. And again, a very important rule here that we have to remember, why we are seeing the 14 network when we have passive interface on both of these interfaces. Well, the reason we are still seeing this on router 3 is because we have to remember that the router is still going to advertise the interface in which we have passive interface on. It's still going to advertise that interface in its normal updates. Okay, so let's go ahead and take a look at this again here from router 3's perspective. If I do a show IP route, you can see I don't know of the 4 network, but I do see in here the 14 network. Again, like I was saying, the router is still going to advertise the interface address, even though it might have passive interface installed on it. And that's why we're seeing the 14 address, even though both router, router 4 and router 1 have passive interface on their interface here on the 14 network. So it's still going to send this 14 network in its updates. So let's go ahead on router 4 and we'll do a no passive interface default. And what we should see now is we should see router 1, even though it has passive interface on its fast Ethernet 00 connected to router 4, it should get this update here from router 4 and send this update along and process it to router 2 and 3. However, it's not going to send updates. Router 4 is not going to send updates out that interface. Okay, so I just did the command on router 4. On router 1. Okay, so what we can see here is we can see that router 1 now has received the 4 network and it's updating out to router 2 and router 3. So if we look at router 3 and we do a show IP route, now you can see on router 3 we are seeing the 4 network learned via RIP. If we go to router 4 though, you can still see here that we do not see any of the networks from router 2 and 3. So in this scenario here, what we're seeing is when we turned off, passive interface on router 4's fast Ethernet 00, we were seeing updates being sent out router 4. So if I do a show debug, so if I do a debug IP RIP on router 4 now, what we should see now is we're sending updates, version 2 updates to the multicast 224009. Shows here the loopback. What we should see here now is the fast Ethernet 00 interface, and that's exactly what we see right here. So whereas before there were no updates being sent out fast Ethernet 00, now there are from router 4. Router 1 is now receiving these updates, and even though it has passive interface on its fast Ethernet 00, it's going to still update its routing table and send these updates out, but it's not going to send them out the interfaces in which it has passive interface enabled on it, which is fast Ethernet 00, which is back out to router 4. Also, on router 4 we don't see any networks. We do a on all, stop all debugging there. If we do a show IP route, we don't see any other networks in router 4's routing table learned via RIP. And that is because router 1 has passive interface default on its fast Ethernet 00, so it's blocking those updates from router 2 and 3 from getting to router 4. So if we go to router 2, now if we do a show IP route, you can see here that I have the 4 network now in my routing table. And what we can see here though, even though it's in the routing table, we are not able to ping it, and that's because what we have to remember here, if we go ahead on router 4, if we do a debug IP packet, and we'll do a ping here from router 2, what we should see here is exactly what we thought we're going to see. It's seeing the source. It can route to the source, which is 172.16. Actually, it can't even route to that, because if we do a show IP route on router 4, it doesn't even know how to get to the 172.16 network, because those RIP updates aren't being sent out router 1 to router 4. So what we're getting here is unroutable traffic. So even though router 2 has this network in its database here, its routing table, it cannot route to it. And same thing with router 3. If I try to ping the 4 network, and that is because, again, router 4 does not have any information in its routing table on how to get back to the 172.16.0 network. I'm sorry, 172.16.1 network, which is the network that connects router 1 to router 2 and router 1 to router 3. So again, in this lab, we looked at passive interface and what it does, and what kind of problems where you might see it, in a lab scenario where they want you to send updates out an interface but not other interfaces. In that case, we want to do a passive interface, default on all the interfaces that we don't want to send updates out, and then specify, no passive interface on the interface in which we want updates to be sent out. So I hope you guys have enjoyed this video, and I'd like to thank you all for watching.